Hi, I'm Jason with ScienceandMath.com, and today we're going to explore the concept of lenses and explore the concept of light that is bent when it goes into water, which can sort of act like a lens. And specifically what we're going to do is show that we can take an image, something that we draw on a piece of paper, and show how light can reverse and make that image appear backwards. It's very simple to do, and it's actually really fun. So all you'll need for this experiment is a piece of paper. You'll need some sort of marker, some sort of permanent dark marker. You'll need an empty glass, and you'll need a glass of water. So it's very simple material. So let me move this glass of water out of the way. And let me move this glass of water, and I'll just put this empty glass and put it on this plate. And what we're going to do with this blank piece of paper is we're going to draw our image. Now you can draw anything you want. You can draw a dog or a cat or whatever you want, but really to sort of get the basic idea for how this works, it's much simpler to just draw some arrows. So let me go down here to the bottom of this page here and draw a couple of arrows. So I'm going to draw an arrow to the right like this, and I'm going to color in this arrowhead nice, loud and proud, so to speak. Make a nice thick arrow that's very easy to see. And then directly underneath it, I'm going to do the same thing. I'm going to draw another one like this. I'm going to color the head of this arrow in. And then I'm going to make the actual body of the arrow nice and black. And then I'm going to do a third one directly underneath it, just to make sure we have enough where we can easily see what's going on. The reason I'm drawing arrows is because the bending that we're going to do is basically going to reverse the direction of these arrows. So it's going to be nice to be able to see what direction the arrows point. Okay, so the next thing you want to do is take your sheet of paper, and you need to basically set it up where you're looking through a glass. Because what we have is an empty glass here, and what we're going to do is fill this glass with water. So what I'm going to do is put the glass in place, right, like so. And then I need to have some way to prop this up. So what I'm going to do is sort of stand it up like this. I'm going to fold the top just to kind of make it easier to kind of stand up. And then basically I'm going to use a book in this case to sort of put it here. And actually what I'm going to do on the bottom is the same thing. I'm just going to bend the bottom in like this, just so I can kind of lift it and hook it on the bottom of this book like this. Now, if you set up everything correctly, you should have an empty glass, over a plate or something to catch any extra water. And then you should have 2 or 3 or 4 arrows drawn, with nice clear black arrowheads. And you should be able to see through this glass, and you should be able to see those arrows pointing a certain direction. Now, I want you to look very, very carefully. All I'm going to do is fill this glass with water. Look very carefully to what happens to the arrows. 1, 2, 3. Now you can clearly see what's happened. The arrows were pointing one direction, and as soon as we put the water in there, the arrows flipped direction. So it's very, very, again, simple experiment, but it shows something so incredibly important. Actually, it shows 2 or 3 things that are very important. The first thing it shows is that that light that's bouncing off of these arrows and going into your eyes can be bent by, the path of the light can be bent by a glass of water. And that happens just like it does in a lens. A magnifying glass lens or any other lens that you can find is going to bend light as well. And that's what's basically happening here. So in order to really understand the details, what I want to do is I want to tilt this back just a little bit. I'm going to sort of move this out of the way a little bit and tilt it back just a little bit like this so that you can sort of see the arrowheads. So let's pretend your eye is right over here and you're the guy looking through this glass right like this at these arrows. Now when there's no water in here, what's happening is your eye is sitting over here. The arrowhead, the light from the room is bouncing off of this arrowhead, going here, and then it's going into your eye. And the tail of the arrow is bouncing off of this, the light is hitting the paper, bouncing, and you can see the black mark here, and it's going straight ahead into your eye. So when there's no water here, you see the head of the arrow here and the tail of the arrow here. They're traveling more or less in straight lines into your eye. Now, as soon as you put a glass of water in the way, everything changes because water actually bends the path of the light waves. So in this case now, whenever the light comes from the arrowhead, it goes through the glass, but when it goes through the glass, it bends. So it kind of takes a crooked angle off this direction. And the tail of the arrow, when it goes through the glass, it bends and it kind of takes a crooked path through the water there. So if your eye again is sitting over here, instead of seeing the head over here and the tail over here, because it's bent, you see the head over here, and because the tail is bent, you see the tail over here. So the bottom line is here, you see the arrow in reverse because instead of seeing the head over here and the tail over here, the water bends everything around so you actually see the head on the other side and the tail on the other side. And that's what happens when light enters most substances like glass, like water, and things of that nature, is it bends the light. So it's very common when you look into an aquarium, for instance, if you put your face to an aquarium and look around, everything looks distorted. The size of the fish look different, the shape of the fish, everything like that looks different, and that's because the light going through that water is bent. So it literally changes the way we see the world when you have light passing through water like that. And that's what's happening here. And it's very, very cool little demonstration because you don't think that it would work that way, but you just set up your arrows behind a clear glass, pour some water into the glass, and you should see the direction of the arrows change immediately after the water goes in there. So get permission to go do this, guy. Go grab a glass of water, an empty glass, and a sheet of paper, and you can do a very inexpensive, very interesting experiment that teaches you about optics and how light travels and the fact that when light goes through water, it actually bends.